Math 70, Section 5.4, Dividing Monomials. The first example that we're going to be looking at, and hopefully you printed the notes, and I'm just going to use the book and go through them with you. So the first example is A says 6 to the 5th divided by 6 to the 3rd. So if you think about that, you've got 6 times 6 times 6 times 6 times 6. There's 5 of them. And 3 6s on the bottom. For each 6 over 6 is equal to 1. So what you have is 6 times 6, which is 6 squared, also known as 36. 6 squared is 36. Okay, you could also apply the rule. If the bases are the same and you're dividing, what you do is subtract the exponent. So 5 minus 3 is 2. So you keep the base the same and subtract 5 minus 3 is 2. And that's the rule we're going to be using. So for B, you have n to the 6th over n to the 2nd. You're going to keep the base the same and subtract 6 minus 2, which is 4. And letter C, bases are the same and you're dividing, so your answer is -7 to the 2nd power. And whenever it's a number, you always want to evaluate it. So -7 squared is 49. Example 2. Now we are going to use some variables along with coefficients. So you have 25 over 15. You are just going to do what you normally do and reduce each of these by 5. So 5 goes into 25 5 times, 5 goes into 15 3, and then you've got 9 b's on top, 6 b's on the bottom. Subtract 9 minus 6 and you get b to the 3rd. For letter B, I would reduce these by 2, the 24 and the 10. 2 goes into 24 12 times, but don't forget it's -12. And 2 goes into 10 5. And as far as the x goes, you have 2 x's on top and 3 y's on the bottom, or on the top. 3 y's on top, because it's 4 minus 1 and also 6 minus 4. They're both on the top. In a minute, you're going to see what happens when you have some left in the denominator. So, what do you do when you have a power rule? You have a quotient and you have a power outside. All you're going to do in this example, example 3, is z to the 3rd, you're going to distribute that 2. Think of this as z to the 1st over 3 to the 1st. And then you've got a squared. You're going to multiply. This is that power to power rule. So 2 times 1 is 2, and 2 times 1 is 2, and 3 squared is 9. So your best answer is z squared over 9. And we have 2 more examples that are going to do the same thing. This 3, think of this as you've got a -2, a y, and a z. You have to cube all 3 of these. So you're going to cube -2, which is -2 times -2, -2, which is -8. And then y to the 3rd over z to the 3rd. So basically you're distributing that 3. And for B, you're going to take 3, raise it to the 4th power, which is 81. And then 2 times 4 is 8. And 3 times 4 is 12. Okay? Example 5. Now we are going to talk about whenever you have 0 as an exponent, that is equal to 1. And we talk about it right here. So if your bases are the same and both of your exponents are the same, when you subtract, you get 0. And you can't, think of this as equal to 1. Anything over itself is 1. So therefore, any number to the 0 power would be 1, basically. So for these ones, let's just go through these examples really fast. Any number to the 0 power is 1. Anything to the 0 power is 1. Now this, you're distributing that 0. So it's 1. Now this one for D, only the W is raised to the 0 power. So the W to the 0 power is 1, so it's 1 times 8, so it's 8. Again, negative 5, anything to the 0 power is 1. Oh, actually, this one, I'm sorry. This one is different because it's negative 5 to the 0 power. This is really negative 1 times 5 to the 0 power. So this is equal to 1, and then 1 times negative 1 is negative 1. Now, if it were negative 5 to the 0 power, that is equal to 1. So that's tricky. And for F, the whole thing is raised to the 0 power, so that's 1. Okay? Next example. Whenever you have a negative exponent, what you're going to do is you're going to turn it positive by moving, if it's negative in the denominator, you're going to move it to the numerator and make it positive. If it's negative in the denominator, you're going to move it to the numerator. So wherever it's at and it's negative, you're going to change its location and make it positive. So for example, if you look at example 6 right here, 2 to the negative 3 power is 1 over 2 cubed. So you're flipping that 2 and you're making that power now a 3. And by the way, 2 to the 3rd power is 8. For example B, you've got negative 5 raising it to the negative 2 power. So you're going to make 1 over, you're flipping it, so it's 1 over the negative 5 now becomes a positive 2, and negative 5 squared is 25, so that's 1 over 25. And for C, be careful on this one because that negative is not, the 4 does not have a parenthesis around it, so it's really negative 1 times 4 to the negative 2 power. So only this gets flipped, so this is 1 over 4 squared, which is 1 over 16, and then multiply that by negative 1, so negative 1/16. Example 7. Okay, now this is asking you to add. So we have 2 to the negative 2 power, which is really 1 over 2 squared, and 4 to the negative 1 power is 1 over 4 to the positive 1 power. So this is really 1/4, and this is 1/4, and when you're adding, as long as the denominators are the same, you keep the denominator the same, add the numerator, and that's otherwise known as 1/2 if you simplify it. Okay? Next set of problems. What do you do when you have negative exponents, but you're now dealing with variables? Same thing. So to turn a negative exponent to be positive, you're going to flip it. So for example 8a, you've got x to the negative 4, so it's 1 over x to the positive 4. Only move the variable that has a negative exponent. So for b, you're going to take this and make it 1 over negative x to the positive 4. And for c, this is going to be negative 1 times 1 over x to the 4th power, or negative 1 over x to the 4th. Okay, example 9. Example 9 is showing you a few things that you need to be careful with. For example, for A, only the A has a negative exponent. So you're going to keep the 2 in the numerator, and you're going to move that A and make it a positive 3 in the denominator. But for B, the whole thing is in parentheses, so you're going to put the whole thing in parentheses and make it a positive 3. And you could simplify this by distributing that 3. You're going to raise the 2 to the 3rd power in the A, so it's 1 over 8a to the 3rd. And for letter C, you're going to take 1 over negative 2a, raise it to the 3rd power, and now cube negative 2, which is negative 2 times negative 2, that's negative 8, and then a to the 3rd. Hopefully this makes sense. Okay, example 10. Okay, so now we're going to look at, we have some in the denominator. And what are you going to do? This is example 10. So this 2 to the negative 3 is in the denominator. We're going to move it to the numerator and make it a positive 3. So that's 2 to the third, which is 8. Keep the 7 on top and bring that n squared on top. Make it a positive 2. And for C, the 8 and the 3 stay right where in their right places. The n to the negative fourth, that has to come up and make it n to the positive 4. So only move what has a negative exponent. Okay, 11. Okay, so now we've got 3 over 2. The whole thing is negative third power. So the negative says flip it and turn this into a positive 3 power. So you're cubing 2, which is 8, and you're cubing 3, which is 27. 3 times 3 times 3 is 27. Okay, example 12. Okay, we have this whole thing raised to the negative 2 power, so we're going to flip that and make it a positive 2 power. So all you're doing is flipping and making a positive 2. So, so now what you can do is you're actually going to square the negative, the 4, and this x to the third. So you could also think of this as a negative 4. It's if you want to do that, or you just have to square all 3 of these. So negative 4 squared is 16, and x cubed squared, remember you multiply these and you get 6. So that's your answer. And example 13. Okay, we have this crazy problem. It says 3 over 2, a to the third, b to the negative 2. You're going to multiply negative 12, a to the fourth, b to the fifth. Okay, so you're multiplying here. You're going to simply multiply your coefficients like we did. 3 over 2 times negative 12. 2 goes into 12 6 times, so this is negative 18. Now, if bases are the same, you're going to add, and you're multiplying, you're adding these, so a to the 7th power. And bases are the same, you're going to add negative 2 and 5 is 3. B to the third. And that's your answer. And last problem, number 14, it says negative 27, and we have an 18. And you've got a to the 7th, a to the negative 2, b to the negative 6, and b to the second. Now there's a few ways you can do this problem. First of all, just simplify that like you normally would. So 3 goes into both of these, or you can say 9. 9 goes into both of these. 9 goes into each of these. This is 3 and this is 2, so negative 3 over 2. Now, what you could do is you could subtract. You could do 7 minus negative 2. Or what you could do is move this up on top. So you've got a to the 7th times a to the 2nd power. And for this one, you're going to move this b, you're going to move it down here and you're going to keep the b squared, and you're going to move this b to the 6th down. So now simplify. You've got negative 3 a to the 9th power over 2b to the 8th power. So you can move your negative exponents and then add, or what you can do is you can subtract. People get a little bit more confused by the subtraction rule. So if you did it, it'd be 7 minus negative 2. That's where you get your a to the 9th. And then negative 6 minus 2, which is negative 8. And then, so that's why you'd bring it down and make it a positive 8. So either way works.